Our final speaker this morning is Yiqun Tsai from Alibaba. Yiqun is a vice president at the Alibaba Group, where he leads the team that's responsible for the research, development, planning, and operation of the network infrastructure. And that's the network infrastructure that supports all of the business units of the Alibaba Group, which are many, and its affiliated companies. So before joining Alibaba in 2016, he was with Microsoft for 4 years, which is where I think I got to know him first, working in the Windows Azure networking group. And before that, he was for 15 years at Cisco Systems, where he helped develop several generations of router software. So Yiqun's team at Alibaba has done some of the most interesting and novel work with P4. They've developed and deployed new applications into production, and I'm looking forward to him talking about that today. And I'm delighted that he'll be telling us about the extent of some of their work. So over to you, Yiqun. Looking forward to this.
Thank you, Nick. Thank you so much. Hi everyone. I'm so glad to be here. So honored to have a chance to speak today. Yeah, in the next 20 minutes, I'll try to share some of the work that we do with P4 and with building network programmability in Alibaba. We have invested quite a lot in these two areas in the last few years, and I hope that you'll find that what I'm going to talk about very interesting and helpful. And of course, by sharing our experiences, I would like to welcome your ideas and suggestions, and we also look forward to collaborations in many, many areas. So let me start. How do it? Yes, first I want to start with a very brief introduction of our company, right? I don't know how many of you know about Alibaba. Our company is essentially a company of many lines of businesses. It encompasses, things like e-commerce, payment, logistics, even entertainment, right? There are many of them. And if you have a chance to visit our campus in China, in Sunnyvale here in California, you probably will see some of those animal mascots. And in our company, our tradition is that we represent each business unit with an animal mascot. So if you happen to see one, you can tell somebody that you heard it from me already. So I don't know if you noticed that one of the business that is not represented by an animal is what we call Alibaba Cloud. And Alibaba Cloud is the cloud computing platforms that we built, and it's a fairly good sized one. And it offers various products, IaaS products, PaaS products, SaaS products, and we have a very wide global reach in our cloud computing platforms. But most importantly, within Alibaba, the cloud computing is not just a business for customers, for external customers to use. Internally, our own distributed applications that we built for our e-commerce, for our payment, for our logistics, and so on, they are all built on top of our Alibaba Cloud infrastructure. So you can think of Alibaba Cloud as a platform that is common to serving both internal and external customers. And this is where all the fun and challenge comes from. So I manage the network team, obviously, and in the last few years, our business has grown tremendously, and so is our networks, right? But the challenge that we obviously experienced in many areas, computing, storage, algorithms, supply chains, and so on, they're quite common and they're quite significant. But today I'll just focus on networking, the challenges that we see in the networking, right? When it comes to networking, obviously we only look at a few common things. We very commonly look at things for example, how to scale the network to fully take advantage of the advancement of the silicons. For example, if the silicon speed doubles every 24 months, how can we build networks to take advantage of that, right? And how to scale the network to make sure that as the bandwidth go up, the delay goes down, and also the availability not only remains the same, but also improves. It is much easier to be said than done, and I'll explain that very soon. So in short, what we're looking at is that as the network is really the enabler of the growth we need to make sure the scale, the bandwidth, the latency, the high availability, all those things grow at the speed, if not more than what our customers are experiencing. But here is the problem that we see, right? If you look deeper in it, what we are really equipped with building today's network is really, in my idea, some kind of quite big. For example, when we examine the fundamental technologies, you can trace many of them back to its infant days of the internet. One of the examples is that today, people still assume the dominant pattern of communication is pairwise. And therefore, if you see that all the optimizations of the pairwise communications can easily be seen in protocols and system implementations. Another example is that if we look at the management today, most of the state or event informations were still collected in the order of seconds, not even milliseconds. It is very rare to see informations, operation informations, management informations collected in milliseconds level. That brings to one example that I often use in terms of reliability or availability. People often use the number of nines to represent how good network availability is. 5 nines is pretty good, 6 nines, 7 nines are wonderful. But people rarely compare the number of nines or really consider the number of nines in the context of the bandwidth. What does that mean? What I mean is that, for example, as the number 9 grows, what we've seen is that the number of nines as a measure of availability grows exponentially or grows much slower than the speed of the network in the last couple of decades. As an example, in the last couple of decades, let's say from year 2000 until now, the core bandwidth in data center or any campus network has grown from 1 gigabit to today about 400 gigabit or even higher. But the number of nines stayed at 5, between 5 or 6. If the availability stays at 6 nines, today's network will drop 10 times as many packets for the same duration of the network outage. This is what we're seeing. And this is an experience that I would say we're not very happy about. So you get the idea. It is very, very hard to build network at scale. And simply put, what we are seeing is that the technologies conceived for the 70s, 80s, or maybe even the 90s internet really doesn't work that well in today's network, especially within and between internet scale or cloud scale data centers. So how we started addressing those problems. Now I want to see that what we find is that with network programmability, and especially with P4, we've achieved quite a bit of success in addressing some of those issues. But when we started, it was just a coincidence that back in 2006, our company was presented an opportunity to invest in a startup called Barefoot Networks. The ideas of the technology of telemetries, how to do inbound telemetries using data path programming, and the ideas of P4 that allows us to modify the data path behaviors of a switch. We didn't really find the specific applications when we started working with people at Barefoot Networks, but we figured there has to be something that's useful coming down the line, and we'll make sure that we'll find a very, very good use of it. And the sparkle comes in 2017 in our company when we started deploying RDMA services. I'm not sure how many of you who are familiar with RDMA. RDMA by its name represents, it's called remote direct memory access, although today nobody really says it that way. Right? Basically, it is really representing or refers to a class of networking services that bypasses typical kernel TCP/IP stacks to achieve very, very low latencies between the end hosts. So it's very nice. Everybody loves low latency networks, right? But in networking, nothing comes for free. When it comes to physical limits, one side optimization usually comes at the other side cost. So where does that cost coming from? If we look at RDMA, there are many ways of supporting RDMA. But one very common one today is called Rocky v2. Rocky is an underlying protocol that implements RDMA, and it refers to RDMA over Converged Ethernet version 2. In a simpler word, Rocky v2 is basically UDP. So over the years, people put lots of effort into Rocky v2, and we also have advanced quite a bit. But in essence, it's a technology, and its associated mindset and tool set is actually from quite decades ago. The good thing is it's tested and true, but the bad thing is, or the undesirable thing is, it is really being stretched when the network is supporting 100 gigabit. I'm sorry, not 100 gigabit. When the hosts are supporting 100 gigabit network interfaces, and we have core networks at the speed of 400 gig with the latency in the microsecond range, and then we have to do it at scale. And then when we do that, this is where we're seeing the limit being stretched, right? So during our design work to introduce RDMA, among many, many things, we found that telemetry was extremely, extremely useful. And it's a very critical component in our network that can help us solve many, many problems. One of them is that as we deploy RDMA networks, we can have we need very high resolution telemetries that can help us identify where the packets are being dropped. And then we can either take proactive or reactive actions to correct it, so that we can make sure that while we are achieving the low latency in the network, we are not creating adverse actions or adverse outages whenever there's something bad happens. And we all know that bad things will happen in the network. Switches will fail, links will fail. And that is how we actually started the path with programmable networks, by providing telemetries in our networks, right? Now, telemetry is fun, telemetry is wonderful, and we all want informations. But as we're building our network to provide a truly visible into the data center itself, we notice that obviously nothing comes for free again, right? A true fidelity in the network telemetry will require a replicate of almost 200% of the investment in hardware, software, and skill. And obviously that is not really feasible, the way to build networks. So the first thing that we tried out with this is to build P4-based load balancers that helps us to deal with the telemetries much efficiently and cost effectively, and then scale our solutions across our networks. Right? This is when we started to taste the advantage of doing network programmability and the flexibility and a lot of the software feel of P4. And then from there, we essentially spawned two technology directions internally. In one direction, we wanted to take advantage of P4 because it's flexible and because it's really performant on switching fabric. We want to take advantage of that, and then to build very high performance gateways. The gateways allows us to handle hybrid cloud, to handle securities, and to handle edge computation functionalities very well. And in another direction, what we did is we want to extend the INT, the network telemetries, basically extend the technology so that we can do much better flow controls in our network. And then in that way, we feel with these two approaches together, building very performant hardware using network programmability and extending flow controls using telemetries and using network programmability, that allows us to really have a true SDN going forward. Now, here comes 2019. In 2019, we go even further along our path. I believe that if you're serious about software, you have to own your hardware. And the same with us as well, right? We went on this path we believe the best way to leverage our understanding of network programmability and the best use P4 is to have our own hardware. So as we're moving forward, we started building our own design and build our own dedicated hardware to take advantage of P4 programming. As we have own switches as well, so we want to make sure that those hardware device, it's not a switch, it's not a gateway, it's not a server, but it's a mix of all those things, right? We built the same OS platforms for the switches and for those hardware so that we can have a very consistent software-driven management plane that allows us to manage our switch network, manage our gateway networks, and manage our endpoints in a very, very efficient way. We also invested in toolings in terms of how we can use P4 programming better, how we can, as we scale the P4 programs into our network, we want to make sure that the verification is in place. The development can have much faster, much more efficient ways of writing P4 programs, and the resource contention on the hardware switch can be solved before the programs is pushed down, is deployed, rather than when problems happens. And we're deploying more and more of those into more wide scenarios. We deployed our gateways to do securities, to do DDoS protections. We have our gateways in lots of the load balancing situations internally. So overall, we feel that it's very, very good technology, and we've had lots of use internally for it. And then in the meantime, in China and in the US, we started to work with the communities in ODCC, in OCP, to share with our experiences and work with our colleagues to advance the technologies together. So by now, I want to use highlight a few key things that we've done, and I want to see, I hope that it'll give you an idea how successful it can be, right? One of the things, as I said earlier, is one very important thing, our event that's associated with Alibaba is what we call single-stage shopping event. And it's a shopping event that it's a promotional, it's similar to Amazon Prime Day. It's an event that happens on our e-commerce platforms. And it's a very significant date, November 11 in China, for all e-commerce providers and not just for Alibaba. And these days, it is actually becoming more and more global, more and more of a global activity. Now, we started doing November 11 back in 2009, and in the past, in terms of the number of transactions, payments, and obviously the total GMV. But I'm not getting into that. What I'm trying to get into that is that about 3 years ago, maybe 4 years ago, I think since 2016, 2017, we are starting in Alibaba, we're starting to migrate all our e-commerce platforms, the web and the internet scale web and mobile distributed software systems onto Ali Cloud, onto our cloud computing platforms. As a result of that, we essentially built probably, I think I have fairly confidence to say that one of the largest hybrid cloud in the world, and it's global cloud, right? This means that we have to handle terabits of traffic in many, many access points and being really flexible with virtualization, securities, metering, and obviously, as I said, above all, availability, and then to do it fast and agile, right? Because we need to modify the data path according to what our application or what that specific point of access is. And to support that, what we've done in the last couple of years is we deployed lots of gateways using merchant silicons, essentially Tofino silicons, that support P4 programming. And we wrote lots of P4 programs in order to handle that. And the flexibility of the P4 programs really helped us to achieve the performance while at a cost that server farms just cannot match at that rate of speed. So another couple example is what we're doing these days with flow event telemetries. As we said earlier, that the telemetries, the network management, the telemetries has advanced quite significantly in the last few years. And it started from context-based information gathering to packet telemetry. And now what we are working on is really a flow event telemetry. The flow event telemetry that we're working on in the sense is that with the telemetry packets not only contains what's happening, but also contains an aggregation and then a judgment of what's happening. And this, when it's presented to the management plane, we've achieved a very, very final grain detail while at a scale that we can economically afford, right? And the other flexibility that it brings with flow event telemetry is that this architecture, even though I draw it in a single box, it can be very flexibly deployed with switches support P4 program or switches that do not support P4 program but provides telemetries, that we can have different levels of aggregation along the path before we make a management decision on what to do with the network, right? These two, NetC and Lyra, are the work that we have been presented to SIGCOMM. It's part of the research work that we're doing with network programmability and P4. It is also part of the work that we have deployed in our networks, right? Lyra is the work that we did in order to, in a way, you can consider this as providing a better tool set for our P4 programmers internally in the company. What we're trying to do is, instead of asking whenever we write a P4 program, instead of ask the software engineer to understand every pipeline or every switch, we present a network view of the switches. That's why we call it, it's a big pipeline abstraction. So as a developer, for example, writes a P4 program for hybrid cloud gateways in order to support our hybrid cloud, he does not have to worry about underneath how many switches are there, and then how many servers that are capable of handling P4 program. All he sees is a very large piece of big pipeline that can handle his resources and handle his data path logic. And the Lyra system have a front end and a back end that turns into this program, very P4-like, into P4 programs that can manage the actual resource distributedly onto the every switches. And the advantage of this is not just simplifying the deployment developer's task in terms of producing P4 programs, but also allows us to do a network-wide verification of the behavior of the program as well as the correctness of the program. Because today, verifying behaviors of programs in a distributed fashion is still a very, very hard thing to do. So the way we chose to do it is to simplify the abstraction and then allow us to be churning out programs a lot more efficiently. So as we said, one of the things that we do is we've indeed have quite a bit of success, right? But as I want to say is introducing any new technology is actually very hard. And it's even harder if we want to make it scale and expect good results of it. And then for us, one thing that we want to do is that we want to be bold and committed, but tactically, we want to make sure that we don't emphasize certain things while ignores others by pursuing short-term results. And therefore, in terms of network programmability, what we're really trying to achieve, or what we really have taken a path, is to make sure that we follow a path that is complete, that is holistic approaches, that we look at how the platforms can be built and can advance. The platforms include our data applications on the plethora of platforms. The applications include gateways, flow controls, telemetries. And then we also invest heavily on the tools, on the compilers to hope to reach platform independence. In this sense, what we mean is the platform being not just a single device, but we can manage multiple devices and hiding certain hardware specifics to the developer. And then we want to be able to do the network-wide verification. And obviously, very important thing is we want to work with the communities, and because we believe it's still early. As we said earlier, maybe as a parting way, right? We've had some successes. We've invested quite a bit in a few years, and we've seen lots of advantages, a lot of the good things that's about to happen. But in all honesty, we believe we're just starting. As a community or internally as Alibaba, we believe that there's a lot more work that's out there that can help us gain the flexibility and gain the true SDN by investing more in this area and investing in a more complete picture in finding more and more pieces to make sure that the networking really can progress with today's advantage, today's technology, rather than the mindset and tool set of maybe 40 years ago. So that's the end of my talk. Getting back to you.
Thank you so much. Thank you so much, Yiqun. Super interesting. I want to start with where you ended, with we are still just starting. And I'm kind of curious, you and your team have built a number of interesting applications. Thanks for telling us about some of them today. Where is this heading in terms of, are you expecting that most of the growth will be in new applications that perhaps people are P4 applications that people are developing but not yet talking about? Perhaps you have some of your own, but is that where most of the growth is going to be? And you think where most of the investment will be? In other words, is there a lot more opportunity for those beautiful new ideas to find their way into our networks?
Yes, Nick, I think there are both ways. There are two aspects of it. One is obviously in the applications that we've already deployed or we've already developed, for example, the gateways, the DDoS protections, the security side of the things, right? And the load balancers. I think for even in those areas, there's a great potential of seeing more and more deployments into more and more scenarios. Obviously, and then the reason I'm saying this is in our cases, we are really addressing the deployment on the high performance, low cost case. But there are also, I believe, and then I've seen them, and the software control really comes into place. And then that is a great area to be explored for sure, even though the functionality is well known, load balancers, gateways, and stuff like that. So that's one thing. And the other side, obviously, just as I said, there's a lot more opportunities, as the previous presenter mentioned, in the edge computing, in the 5G. And I'm seeing and I expect to see a lot more to come in those areas too, in the production, definitely. Yeah.
So I've seen, I've heard others report that when you're trying to do some of the functions that you described at scale, like load balancing and gateways, when you're trying to do it at the scale that you're doing with software approaches, big software load balancers, you end up having to devote a significant fraction of your server fleet just to those functions, just to spread the traffic across other servers. But it has this beauty of this software flexibility. On the other hand, you can do hardware, and there are expensive hardware, hardware only fixed function commercial boxes. And so you found this middle ground, which I think is, is a kind of a sweet spot for your particular deployment. But are these, at the end of the day, are these functions simple enough that you would expect them to stay fairly sort of static and unchanging? Or do you think that there will be a kind of a rolling out and a continued sort of improvement and enhancement of things like the gateways and the load balancing, et cetera?
So this is how we see, and then this is how we believe. It's a personal opinion, but I think I would like to share as well. Lots of the things, for example, gateway functionality, right? The fundamentals of gateway functionality is well understood by many people. Something goes in, something goes out. We look at it, we manipulate it, right? And then we do a little bit of virtualization here and there. But then when it comes to the actual deployment or actual customer, or the big customer, customers of customer, providers of customer, let's say us, we have so many specific things to it. Let me give a quick example. For example, today, if someone uses a cloud platform, there are two customers. One customer is a college student in his dorm. Deploys only one VM for the whole year. The other customers generally use between 10,000 to 500,000 VMs day to day, depending on his use. They happen to put their VMs on the same data center of a cloud provider. They are getting exactly the same services at the edge today, if we look at it, right? Now, this is good, this is bad. This is good in the sense that, okay, the college student gets the same service, gets the same, availability and stuff like that. This is maybe what we as a cloud providers, what we are trying to do is we want to be able to make sure that when needed, differentiated service can be done. Billings, securities, and things like that, meterings, right? And then error recoveries, all those things can be done properly, right? To the point that we can identify each flows, and every flow has a different policies and stuff like that. In order to do that, those policies are very, very provider specific. What we can do in the ASIC is really to give them a way of defining those things, but actually in the fly, exactly how to manage those is not very easy to do, and it is very difficult to bring into the ASIC. So I would say that's why we find that P4 in programmable ASIC is extremely useful in those cases, is that we can leverage the power and the performance of those ASIC while putting our own logic and business applications to it whenever it's needed. And those applications, even though we know it well beforehand, when it's actually applied, we have to be extremely selective as we're doing it. So the customization, I should say, to conclude, the customization is really the key behind those things, to the customization of the data path. And that's why, you know, the server, the x86 servers is on one extreme. The fixed function ASIC is on the other extreme. Neither work very well. So that's why we need the data path programming in the middle, right in the middle, so that we can achieve the same functionality.
I really appreciate, I think, in fact, the whole community appreciates how forthcoming and open you've been, not only today, but in some of the things that your group has written and published, like the description of HPCC for congestion control. It's really helped, I think, you know, create some concrete examples for the community to discuss and to learn from. And so with that in mind, on HPCC, kind of curious that, you know, because it's very different from many of the other P4 applications that we've seen deployed, like load balancing and gateways, you know, in a way, the more obvious ones where you're looking at a header, making a decision based on that as to where to send it next or whether to forward it. But in HPCC, you're taking that idea further. You say a little bit about how that's worked out and how you see that progressing in future?
Yes, absolutely. So HPCC is part of our effort to use network programmability using this skill to do better flow control. As I said earlier, we really ran into this flow control issues when we started designing RDMA services. And as we're trying to address that, we're seeing that really the flow control, final grain flow control have works to deliver what we called a predictable networking services. So yes, we presented the ideas in SICOM, and internally we've incorporated ideas of HPCC into our low latency network offerings, as well as predictable network services going forward. So this is what we're doing.
Yeah. And you know, now I'm aware of, and you've talked about the programmability within the switches, and you mentioned that you're expecting that to move into the next SmartNICs in future as well. Do you see it going elsewhere? There's a question that we had about moving programmability to the optical layer in the data center or the WAN, or to the radio layer for 5G and radio networks.
I won't be able to comment on the radio layer because that's not what my group's focus yet, but on the optical, yes, we're looking into that as well, because the way we look at the networking when we build such a large network, is we want to make sure that we always take a holistic approach. We don't want to optimize one side while at the other side's cost, right? And then the optical layer, especially on the optical switching between the data centers, maybe not the long haul yet, but between data centers. Long haul is so far is still really the cost driven, but between data centers, there's a lot of switching going on. And then incorporating lots of the SDN ideas into that area is indeed one of the things that we're looking at it. And we're actively working on some.
I see. So does that mean taking information that is sort of normally kind of private to that optical module or transponder, and then making that available perhaps as metadata into the switch that can then add it to packets, or maybe even the transponder interprets the packets and adds it itself, and then makes that information available through, for example, inbound telemetry. Would be that how it might work?
Yes, that's the idea where that's the direction we're going, because traditionally what people do with those information is, okay, maybe the transponder has something, or maybe the transceiver has a problem that cuts down the link, and then all those things aggregate to the network management functionality, sit somewhere, and then there is a person or maybe a group of people looking at their screens. Sometimes you have an optical engineer looking at the optical side of the things, and an IP engineer looking at the IP engineer of things, and the host engineers, they call each other on a conference call to say, hey, is there a problem? That has been the way, I'm pretty sure, for many, many years, and we're changing that. And what we're making sure is all those informations, we're trying to abstract the ideas of the engineers, and we're making sure all those informations get processed as efficiently as possible and as intelligently as possible. If you want all the information to be seen and processed by a human being, it's not going to be lots of information, right? It's going to be not going to be very fast, so you can't have that many nines behind it. But it's if you have a person processing information, I don't know, you'll get 3 nines or 4 nines. You're lucky to get there, right? And then with that, with the speed at 100 gig or 400 gig, I mean, it's tremendous packet of loss of packets when something bad happens, and we just can't afford to have that, right? So that's the reliability and the availability is one of the very, very important driving force for us to make sure that telemetry information is being processed correctly, aggregated properly, processed properly, and then because of that, we can have more and more of them to do it, and then therefore the network really becomes visible, opening up. Yeah.
Great. So thank you so much. We've got lots more questions. They're still rolling in. I encourage you to take a look at them on the Q&A. We're not going to have time for all of them today, unfortunately. But as always, your talk is going to generate a lot of interest and a lot more follow-on questions, as did all our speakers today. And I'd like to thank everybody for their talks, with Michael and Konstantin from Google, and from Timon and Charles from ONF, and Yiqun from Alibaba. So thank you so much. Thank you, everybody, for being here. We have a few more minutes.